Hi, welcome to Math for All, where everyone can learn more about math. Today, we start a journey in the land of functions, and we will answer the question, what in the world is this function that I keep hearing about? Well, I will give you strategies to determine whether a group of numbers are a function or not. First up, we're going to have to learn a definition. A relation is where two variables are obviously related to each other. We can show relations of numbers in three main ways. Mapping, where the x oval numbers are related to the numbers in the y oval by these arrows. I put in a 4, out pops an 8. When I put in 7 for x, I get 14 for y. I can also list points. Any group of points are a relation like these. And we can graph on xy coordinates, either points plopped on it or in a continuous line or curve. Each of these is just a different way of showing the same thing. You can see that relations are typically x's and y's that are grouped together. Now let's get to the meat of this, where we discuss functions. The word definition of a function is a special type of relation in which each x value corresponds to exactly one y value. Maybe it will help if I don't say it so mathy. Basically, every time I put in the same x, I will always get the same y. Okay, maybe that didn't help so much. So let's show how to determine whether a relation is a function using our mapping, listing, and graphing models. Here is a function shown by mapping. I put in 0 and y equals 3. Then I put in x equals 4 and y equals 3 again. Different x values give me the same y value, but that's okay for a function. Next, we will map one that is not a function. 5 goes to 6, 3 goes to -2. Then I put in 5 again and I get 0. That is a no-no for functions. I cannot put in the same x of 5 and one time get a 6 and then the next time get a 0. So when the arrows double up on the next value, that's your clue that this is not a function. How about a list of points? Obviously, we will have a different strategy to determine if a relation is a function because there are no arrows when we just have points. Take these, 4, -2, -2, 7, 7, -2. Remember that the first numbers are the x's, 4, -2, and 7, and we don't have any repeats. So these points are a function. It's okay that there are two y's of -2. It's only the x's that we have to worry about. Here's a group that is not a function, 3, 4, 5, 4, and 3, 0. Notice that I have an x repeat of 3, and one time I get a y of 4, and the other time I get 0. That disqualifies him from being a function. Now let's explore the cool strategy to figure out if a graph is a function or not. We call it the vertical line test, and it just means that everywhere I can put a vertical, which is straight up and down, line, I can hit the relation no more than one time. If I can put a vertical line anywhere and I hit the points or a continuous line more than once, it is not a function. First, here's an example of a function of points. As I put vertical lines along it, my lines hit no more than one point. Next is a cool continuous curve to try. Once again, as I put vertical lines, they only hit at one point. Now, let's look at some that are not functions. Maybe you can spot the trouble child right away with this one, but we'll do some vertical lines and show that the issue is at x equals 3. I have 2 points crossing my vertical line at 3, 5 and 3, -2. So this is not a function. Next up, this cool curve. I will show with just one vertical line that it has failed the test by hitting it twice, so this graph is not a function. Yay for you for learning that relations just relate x's and y's, and that functions are just special relations. And you learned the 3 different methods to determine if a relation is a function or not. I'll see you next time when you come back to learn more about math.